Hi friends, and welcome to this week's What's the Math Wednesday, where I give you guys a math topic and explain it and then provide you with practice problems in case you want to try it out. So last week we started talking about the ambiguous case for the law of sines, except that last week's case gave us an obtuse angle that was given, and this week we're going to talk about what happens when an acute angle is given. So reminding you, this is the formula for the law of sines. It's basically the sine of an angle over the length of the side opposite of it is equal to the sine of another angle over the length that's opposite of that, which is equal to the sine of the final angle over the length opposite of that. So like I said in the first video about law of sines, this will be a 2-ratio proportion. It's never going to be 3, but to present the formula, they have to put the 3 ratios because they don't know what piece of information is going to be given in each problem. So this encompasses everything for you. Okay, so we started talking about law of sines with the ambiguous case last week. And I had said the ambiguous case is when you're provided with 2 side lengths and a non-included angle measure. And included just means between the 2 sides. So if it's non-included, it means it's not in between the 2 sides. When an acute angle is given, one of 3 things happens. You're either going to have 2 triangles formed, 1 triangle formed, or no triangles formed. So we're going to discuss that. So here's this chart that tells us how to recognize if there's no triangles, 1 triangles, or 2. So you'll see a couple letters that I use. H represents the height of the triangle. And to find that value, you would do B times the sine of A. So basically what that means is the sine of the given angle times the side that is not opposite of that angle, which is why it's lowercase b and not lowercase a, because the lowercase a is the side opposite of that angle. So B sine of A is the height of the triangle. Capital A represents the given angle, lowercase a represents the side opposite of that angle, and like I said, B represents the other given side, so the side that's not opposite of that angle. So if you solve for H, because sometimes people forget that there's a relationship with A and H, so I have other things that we can talk about as well. But if you remember that there's a relationship with A and H, you'd want to follow this. So if A, again, A is the side opposite of the given angle. If A's value is less than H's value, then no triangles are formed. If A's value is equal to H's value, then 1 triangle is formed. And if A is greater than H, then 2 triangles are formed. So like I said, though, sometimes people forget that there's a relationship with A and H. And if that's your case, like if you're in the middle of a problem and you're like, oh no, I don't know what to do, then follow this. So if you know that A is less than B, and when you're solving for the sine of B, you find out that B's value is greater than 1 or it's less than -1, then there's no way that can form a triangle because the sine of B has to be in between -1 and +1. So your sine can basically be from 0 to 1, but nothing greater than that. So if it's greater than 1 or it's less than -1 and A is less than B, then you're not going to have a triangle at all. And you would say like no triangles formed. If A is greater than or equal to B, or if the sine of B is equal to 1, then you're going to have 1 triangle. And then if A is less than B and your range for the sine of B is between -1 and 1, then you're going to have 2 triangles. And don't worry, guys, I'm going to show you what this all looks like. So if you need to like copy this down for yourself, go for it. Pause the video. And when you unpause it, we'll start the example, which will be now. So here's example 1. So example 1 tells us A is 38 degrees. lowercase a is 58 and lowercase b is 65, and they want us to solve the triangle. For the sake of the length of this video, we're just going to solve for the measure of angle B. But what they mean by solving the triangle is solving for every angle measure and every side length in the picture. So just an FYI. And if anyone wants me to do an example where I solve for the triangle, just let me know. So what I like to do first is I like to draw the picture. So this would be our picture. So angle A has a measure of 38. The side opposite of that angle is 58. The side opposite of angle B is 65. So that's what my picture looks like. Now, if I wanted to solve for H, because, you know, we know that there's a relationship with A and H, that's what I'm going to do. So H is B sine of A. And again, if they're not using those letters, it's the side that's not opposite of the angle times the sine of the angle. So 65 is the side that's not opposite of the angle, and the angle is 38 degrees. So 65 times the sine of 38 gives you 40.018. If you're comparing A and H, A is greater than H. So as a result, two triangles are formed. Okay, so let's solve for the measure of angle B. So we're going to use all of the information to directly solve for that. So we set up the law of sines. Now, just an FYI, if you look and you're using cross products here, 65 times the sine of 38 equals 58 times the sine of B. That's basically H on the left side. So like H equals 58 times the sine of B. So if you take your H value and you divide it by your A value, you'll get what the sine of B equals. But that's just like a little like, hey, look at this moment. If you don't remember that, don't worry. You can set up the whole problem and just keep doing it. So we set up sine of 38 over 58, because that's a sine of capital A over lowercase a, equals the sine of B over lowercase b, which is 65. We use cross products like I was saying. We get 65 times the sine of 38 equals 58 times the sine of B. I isolate my sine of B by dividing by 58. And then I use inverse sine because I need to solve for the angle measure. So inverse sine of 65 sine of 38 over 58 is approximately 43.63. So that means one value of angle B is 43.63. Now, you're probably saying, I don't understand why there could be two values. And here's the reason why. In trig, if you think about like the XY graph, the Cartesian plane, there are two places where each trig function is positive and each trig function is negative. For sine, that would be the first quadrant and the second quadrant. So basically, angles that are located in the first quadrant, which range from over 0 but less than 90, those are considered reference angles. So you would use that value to find the other angle, which is what we're going to do. Because our angle, which we said was 43.63, is located in the first quadrant. So we're going to use that measure to find the angle that's located in quadrant 2. And to do that, you take 180 and you subtract the reference angle from it. So we would do 180 minus 43.63. Because again, if you think about like, why am I taking 180? It's because the max in quadrant 2 is 180 degrees. And this is really throwing to the unit circle and reference angles. So that's where this is coming from. Again, if somebody would like to see a video on this, let me know. Excuse me, guys. Okay, so then if I know that the first value of angle B is 43.63, I take 180 and I subtract that from it, and my second value of B would be 136.37 degrees. Now, just as a side note, guys, when you have two different triangles, things to just keep in mind. the provided information will be the same for both triangles. So angle A in both triangles is going to have a measure of 38 degrees. Lowercase a in both triangles will have a length of 58, and lowercase b in both triangles will have a length of 65. So the only things that will change between the two triangles is going to be the measure of angle B, the measure of angle C, and the length of lowercase c. So the things that are missing are the things that would have two values in this case. Okay, here's example 2. So in example 2, it says the measure of angle A is 70 degrees, lowercase a is 22 yards, and lowercase b is 25 yards. Solve for the measure of angle B. Okay, so I drew a picture for us to get us started. Okay, so this time I didn't want to solve for h just because I wanted to show you what you would do in case you forgot that h even existed. So I set up my law of sines. So I do the sine of 70 over 22 equals the sine of b over 25. I do my cross products. 25 times sine of 70 equals 22 times the sine of b. And I solve for b. Well, I solve for the sine of b. And by isolating it by dividing by 22. So I have the sine of b is equal to 25 sine of 70 over 22, and that will give me approximately 1.0678. So because this value is over 1, no triangles are formed. Now, if you wanted to solve for h in this case, you would do 25 times the sine of 70. H would be approximately 23.4923. And we know that since A, which is 22, is less than H, which we just said was 23.49, we would also know that no triangles are formed. So I just wanted to show you a different way or a different approach if you didn't want to solve for H, or you forgot to solve for H and you didn't know what to do. So anytime the sine of the missing angle is greater than 1, or like I said, less than -1, no triangles will be formed. And that's what your answer would be because you can't do the problem. Okay, example 3. In triangle ABC, lowercase a is 20 inches, lowercase b is 15 inches, and the measure of angle A is 80. Find all possible values of angle B to the nearest hundredth of a degree. Okay, so hundredth means 2 decimal places in case, you forgot. Here's the picture. Okay, so again, if you forget about h, you would do this. You'd say, okay, sine of 80 over 20 equals the sine of b over 15. You do cross products. 15 times the sine of 80 would equal 20 times the sine of b. You'd isolate b, or the sine of b rather, and you'd get 15 sine of 80 over 20. And that would give you 0.73861. Okay. Now, you could say, oh, well, I didn't solve for h, so I don't know how many triangles this actually forms. This has to form at least 1. So we're going to approach it like, okay, this forms 1, and we'll see whether or not it forms 2, just to give you a test. Just as a side note, if you did solve for h, you would do 15 times the sine of 80, which would give you approximately a value I didn't write down. Here we go, 14.7721. So what that tells you then is A is greater than B, which is greater than H, and that would give you 1 triangle. But again, I just want to show you how to approach this in case you were like, I forgot about H and I don't know what to do. So once you get to this point, right, the sine of B is approximately 0.73861. So you're like, I know this at least forms 1 triangle, don't know if it forms 2, so let's see what we can do. Okay, so first thing you'd want to do is solve for the missing angle. So you would do inverse sine of 15 sine of 80 over 20, and that would give you approximately 47.61. So at least angle B has that measure. Now you say to yourself, okay, if this had a second measure, like if there were 2 triangles, I would do 180 minus 47.61. I would get 132.39. But here is the problem. If you were to add 132.39 and the 80-degree angle, which is angle A, you would get 212.39, which contradicts the laws of triangles, because you know that the interior sum of a triangle has to equal 180 degrees. So if this value exceeds the appropriate sum for the three angles in a triangle, it doesn't form two triangles, it only forms one triangle. So there is only one triangle in this case, and that value then for the measure of angle B would be approximately 47.61 degrees. So again, if anyone would like me to explain any of these examples further, just let me know, just comment, or like rewatch the slides. But I have no problem making separate videos for you guys if you want me to go through the examples further or explain some other thing or topic that I talked about in a slide. Just let me know. So I've now shown you an example where there's two triangles, one triangle, and no triangle. And now I'm going to leave you with you-dos. I will give answers to those you-dos later. So if you want to try them, I'd love for you to try them. And yeah, have a great day. So here's you-do number 1. So I'd like you to solve for the measure or measures of angle B. And I'd like you to round your answer to the nearest hundredth. So remember, that's 2 decimals. And just again, just a reminder, your calculator should be in degree mode. Also, guys, all of these problems, the examples and the you-dos, I made myself. I spent all day yesterday like making up problems and making sure they all worked. So I hope, you find them interesting and cool. Okay. You-do number 2, solve for the measure or measures of angle B and round the answer to the nearest hundredth. Again, that's 2 decimals. And then our last you-do, solve for the measure or measures of angle B and round the answer to the nearest hundredth, which again, 2 decimals. All right, guys, have a great Wednesday, and I can't wait to hear from you guys. Leave me some love. Bye, guys.